Cool, so let's continue. Going to go back to the sim, make sure we have a low res, let's hit play. Okay, cool, this is our sim. And what we need to do is we need to first initialize where we're going to be creating this curvature mask. So the first thing we need is a gas match field, and let me delete this guy because I've already done a test. And we're going to need a the idea is to copy the curvature or remap the curvature and copy that information into the temperature, inject it into the temperature. Now, again, this is a spoiler for week 4, but basically you don't have to think of temperature as something that always needs to create fire. For example, I'm calling it temperature, but I can create anything. You see this gas buoyancy here? It takes the temperature field and then it causes the smoke to behave or go upward, follow this direction here, which is basically changing the velocity. So we can create any data here and use a buoyancy with it. So for example, I can create this crack mask and then give this volume a negative buoyancy to go in this direction, and I can use this mask to push the volume back, or we can cause it to go up, or we can cause it to go down, for example, or we can create two of them. We can create, let me go here, we can create a 2 gas buoyancy and isolate the cracks to have a positive, to move the data forward, and then reverse that mask and use another buoyancy to move the other volume backward. And again, we'll continue this in week 4. So for now, I'm going to consider it as temperature for now, because we're going to display it as well as fire. So it's a scalar field. I'm going to copy this. Gonna disable the cooking, and let's call it curvature. Cool, so we need to compute that. So I'm gonna add a merge node, and next to the gas analysis I'm gonna copy this and I'm gonna call it curvature, and we want to compute the curvature for the density field. Okay, now we need that curvature data, we need to remap it. So I added a merge here, and we're going to create a gas field VOP. Okay, and dive inside. Let's bind, it's fine. Let's bind import the curvature. Let's fit range this, because we know it goes from 0 to 50, for example. That's what we did in the viewport. This is assuming that we will get the same result in the sim, and we can always, actually, you know what, I'm not going to remap it at this point, only when we need it. I'm only going to plug it through a ramp and isolate it the same way we did, and then we're going to export it back as a curvature. I don't want to create another temp. We're just going to change it and export it back. So let's go up, and what we did is we set this to white, or blue and red, and then let's set this to black. No, I think I did the other way. Yeah, I think it was like this. Anyhow, we'll figure it. We'll fix it when we need to. Cool. So the next thing is we need to advect this field here before we inject it anywhere. So I'm going to copy the gas advect field, and then I'm going to advect the curvature, and now we need to inject it into our sim. Now we can obviously do a lot of things with it, but for now I'm going to start modifying the temperature. So I'm going to copy this gas calculate, and the destination field is temperature, and what we want to inject is the curvature. Method is add. Let's increase that to 100 so that we can see a drastic change in the sim. And let's make sure we have some buoyancy. Even though we don't have to have a buoyancy, we can still get the look of it and everything. And what's going to happen, I'll explain what's going to happen once we get the result going. Now remember when we did the gas analysis, the result was very, very sharp, and we added a gas blur. We blurred the result a bit for the density before we plug it, but we don't want to blur the density here because that's going to change our sim. So I'm simply going to blur the actual curvature map itself. This is not ideal. I think it should be fine. We don't have any radius. Let's leave this, set this to 0.4. Turn off the multipass blur because it tends to go a little bit too aggressive. So let's hit play. Nice. And we have display as well. Cool. So I think it's working. But the sim is now completely different. Now let's set this back to 1. And I'm not really looking at changing the sim, to be honest. It's going to change we can change it in any way we want. We can cause those cracks to go upward if we wanted to, but I only wanted to add the fire, add that information into the temperature and explain something. So basically, when we have these lines converted into a temperature, the next frame the temperature is going to get advected, and then there is a new cracks that's going to appear, and those will also be converted into a temperature. So we'll get this result advected over time plus this new one, and then it's going to start cooling. So we'll get a recursive addition of the temperature, okay? And it's going to keep building up every frame. And the decay is controlled here. So right now 25% of it is getting removed. And you can see, let me go to multi, and let's increase it so we can see it better. And I'm using the density as a multiplier so I can mask it. Yeah, otherwise it's going to show up everywhere, and we'll understand more about this next week. So we'll multiply the data by the density for now. And let's set this to 10. Set this to 1. And I'm gonna work on these colors a bit. Okay, let's see. Cool, so now it starts analyzing the sim, finds the curvature, injects those into the temperature, and then we get our first temperature field created. So what I'm going to do is actually let's add a little bit of buoyancy to this. That's probably too much. I'm actually going to lower the diffusion that blurs the result over time. I'm gonna lower the cooling so it sticks with the sim for a lot longer. And for some reason the buoyancy is pushing the smoke down instead of going up, and I'm not so sure why is that at the moment. Maybe the curvature information that we have is negative or something. So let's reverse this to 0.1, -1. It's too much. Let's set this to 2. I'm going to increase this to 1 for a high resolution. I'm just gonna quickly sim a couple of frames here to show you guys the result. And now with this, we don't have to inject temperature. We don't have to copy this information into the temperature. We can create a gas buoyancy, for example, and add this information in there and move the smoke in any direction we want. For example, we can use it as a mask. We can analyze the sim in any way we want. You can see now it's changing a lot, but I think the idea is there. And this is how we can create fire. Now I think because we're constantly adding this result that can go from 0 to a very high number, we're gonna get exploding fire, so we need to add another gas field VOP and tune this down. But for now, I'm only interested in the look, adding that fire without changing the sim. I can do that. So I'm gonna set the buoyancy lift to 0, and we should still get our fire information as it is. And then I'm gonna run a couple of frames and show you the result in the next video and talk about the assignment. Thank you guys for watching, and see you in a bit.